5, Section 1.6, Applications of Linear Functions. All right, so because these are applications of linear functions, we are going to be making linear equations to solve. So a few steps, and these are steps that I would grade for on the final exam when you do turn in work for this. So solving the application problems. Step 1, read the problem carefully and assign a variable to represent what you need to find. Again, the variable is the thing that's the unknown in your problem. Then you're going to go ahead and write an equation to solve the problem. Third, solve it. And fourth, check the solution. A fifth step, which I forgot to include here, is you need to write a sentence. Okay, write a sentence about your problem. It is a word problem, so answer in word form. All right, let's take a look at a geometry type of problem. The length of a rectangular plot of land is 3 acres less than twice the width. The perimeter is 54 acres. Find the dimensions of the plot of land. All right, so we're talking about a rectangular plot, so I'm going to go ahead and draw a diagram for this. Now, if you draw a diagram, you don't need to write out let x equal and whatever your variable is. You can just label your picture. So let's see, we know that the length is going to equal what? 3 acres less than twice the width. Well, what is the width? We don't know, but let's call it W. So then L is going to be 3 minus twice the width. So it's twice in the width and it's taking 3 away from that. And that's my length. Now what else do we know? Again, we need to try and create an equation. Well, we know that the perimeter is 54 acres. And what do we know about perimeter? Well, perimeter is when you add up all of the sides. So adding up all of the sides would be just the same as writing 2w, so 2 times w, plus 2 times the length, or 2 times 2w minus 3. And all of that together, the total of all of the sides added up together should equal 54. And there we go, we have our equation. All right, so let's go ahead and solve. I'll go ahead and distribute in that 2, and then I have 2w plus 4w minus 6 equals 54. Adding up the w's, we get 6w minus 6 equals 54. Go ahead and add 6 to both sides, and we have 6w equals 60. Ooh, dividing by 6, and we have that w equals 10. Okay, so let's think about this. Does this make sense? If w is 10, then this side should be 10. And then what should the length be? Well, that's going to be 2 times 10 minus 3, which is going to equal 20 minus 3, which is 17. And that makes sense. They're both positive numbers. Okay, so my final answer, again in word form. The land is 17 by 10 acres. All right, so let's go ahead and move on to the next problem. Example 2, the perimeter of a triangle is 5 times the length of the shortest side. Then the length of the longest side is 9 centimeters more than the length of the shortest side. The length of the medium side is 5 centimeters more than the length of the shortest side. Find the lengths of the sides of the triangle. A lot of information, but I know I'm talking about a triangle. However, I don't know if it's a right triangle, so I can't assume that. It doesn't tell me. But let's see. All of this information is always talking about which side? They're all referring back to the shortest side. So because of that, I'm going to go ahead and make my variable s for the shortest side, because I know all the other information is tied into that. And then I can go ahead and build on that s to find out the lengths of the other sides. So again, the longest side is what? 9 centimeters more than the shortest. So that's going to be s plus 9 is going to be the longest side. And then the length of the medium side is what? 5 centimeters more than the shortest. So that's just s plus 5. Awesome. So all I need to do is find a way to tie this all together to make an equation. And what piece of information have I not used yet? Well, I know the perimeter is 5 times the length of the shortest side. So that means that perimeter is, again, is the same as equal in math. Is the same as equal. P is 5 times s. They look very similar, so be careful with 5 and s. All right, and again, how do I find perimeter? Well, I just go ahead and add up the sides, and I'll get the perimeter. So this is going to be s plus 9 plus s plus 5 is the perimeter, and that's supposed to equal 5 times the shortest side. So let's go ahead and add up the left side. So it's going to be 3s plus 14 equals 5 times s. I'm going to go ahead and get the s's on one side, so minus 3s minus 3s. 14 equals 2s. All right, let's go ahead, still solving for s, divide by 2, and we have 7 equals s. Awesome. Okay, does that make sense? Yes, all of the sides will end up being positive numbers. So let's see. 7 plus 19 is going to be 16. The other side is going to be s plus 5. So 7 plus 5 is going to be 10. Oh, 12. And then s is, and we found out s is 7. All right, good. So we're done. It makes sense. Let's go ahead and answer in a complete sentence. Does it tell us the units? Centimeters. We're talking about centimeters. Okay, so my answer is going to be in centimeters. Let's see. The lengths of the triangle. Are 12. Let's actually start with the small. 7 by 12 by 16 inches. Ooh, not inches, centimeters. Almost did that wrong. Again, be careful, use the right units. So we're talking about centimeters. All right, moving along. Now we're talking about mixture problems. Let's see. A mixture of hand sanitizer needs to contain at least 60% alcohol to effectively kill most germs. An 8-ounce container of hand sanitizer is 22% alcohol, too low. So we need to add to it. So how much pure alcohol needs to be added to obtain a mixture of hand sanitizer that is 60% alcohol? So I'm going to go ahead and make a visualization of this. We have a certain amount, right? A container of alcohol, and we found out it's too low in percentage, so we needed to add something to it, and then we're going to come out with an outcome. Let's go ahead and fill this in with what we know. For the first item, we have an 8-ounce container, and it's 22% alcohol. So it's 8 ounces and 22% alcohol. And again, my unit is in alcohol and ounces. Now I need to add to it pure alcohol. Okay, we're adding pure alcohol. What is pure? Well, that's 100%, right? So we're going to add 100%, and we want to end up with 60% alcohol. So that's my outcome. I want 60%. Now, do we know how much of the 100% I'm going to add? We don't. That's my variable. We want to know how much. So again, I'm just going to go ahead and say X ounces. We do not know how many ounces. And then after I add that up, how many ounces will I end up with? Well, I don't really know, but I know I start with 8 and I'm adding X amount. So the end amount is just going to be 8 plus however much X I put in of ounces. Okay, so now we're going to go ahead and create an equation in percentages. So we'll do that by just multiplying the ounces by the percent. So my equation will be 8 times, and careful, we can't put a percent into equations, so we either need to be working with decimals or fractions. I'll go ahead with the decimals. So 22% is 0.22 plus, and then this is going to be X times the 100%, which is just 1 technically, right? So 1 equals, and then we have 8 plus X times 0.6. Again, you could do fraction if you want. Now multiplying this out, I'm going to get 1.76 plus X equals, I'll go ahead and distribute that other side out, and that's going to be 4.8 plus 0.6X. So I'm going to go ahead and subtract X to the other side. I'll make it positive on this side, and then I'll subtract the 1.76 to the other side. And let's see, we'll end up with 0.4x equals 3.04 dividing by 0.4. What do I get? I get x equals 7.6. What does that mean? Again, that's the amount of pure alcohol I'm pouring into my mixture to get the amount that I wanted. So how much pure alcohol needs to be added? We need to add 7.6 what? Ounces of pure alcohol. Had a brain fart there. Spelling out alcohol. We need to add 7.6 ounces of pure alcohol. And there we go. We're done. All right, so we have another mixture problem. Go ahead, try this one out by yourself and check it back in with me. So hopefully, again, you tried this out by yourself, but let's see what's going on. So we have a 20% acid solution for an experiment, and he has 3 liters of a 34%, and we're going to assume it's an acid solution. How many liters of a 10%, again, assuming acid solution, needs to be added to dilute the acid solution to a 20% acid solution? Again, so what's going on? Visualizing. Let's see this. Visually, we have one amount. He has a 20% solution. Oh, no, he needs that. So he has 3 liters of a 34% solution. We're going to add to it what? Well, we don't know. How many liters are we adding? So again, I'm going to make that my variable. We don't know. But we do know it's going to be a 10% solution. And we want to end up with a 24% solution. So we have to dilute it to 24%. Oh, not 24%, 20%. And then do we know how much we're going to end up with? Well, not really. We just know that it's going to be the 3 plus x. Alrighty, let's go ahead. Again, same concept. We'll go ahead and multiply out for our percentage equation. It'll be 3 times 0.34 plus x times 0.1 equals 3 plus x times 0.2. All right, let's go ahead and distribute. Ooh, wrong color. And what will we get? We have 1.02 plus 0.1x equals, and that's going to be 3 times 0.2, which is going to be 0.6 plus 0.2x. All right, so let's go ahead, subtract 0.6 from both sides, and then subtract the 0.1x from both sides as well. And what will we get? So 1.02 minus 0.6 is going to give me 0.42 equals, and then we have the 0.2 minus the 0.1, so that's going to be 0.1x. And then dividing both sides by the 0.1, we end up with 4.2. So what is my answer? Again, what are we trying to find out? We're trying to figure out how many liters of the 10% need to be added. Again, that's what we're looking for. So that means we need 4.2 of the 10%. So we need to add 4.2 liters of the 10% acid solution. Yep, okay. All right, moving along. Let's take a look at direct variation. This is proportion or comparing quantities. So a number y varies directly with x if there exists a non-zero number called k, which we call the constant of variation, such that y equals k times x, which is considered varies directly, or another way to say that is directly proportional. So for example 5, if y varies directly with x, again, what do we know with directly with x? That looks like y equals k times x, sorry. And then we know that y equals 10 when x equals 3. Find out y when x is 18. So there are a few steps in this problem. First, we have our equation, and we need to figure out the constant of variation in order to solve my problem. So first, we're going to go ahead and do that. We need to find out what k is. Now, my generic equation is going to be y varies directly with x, and we know how to write that. That is y varies directly with x. So whenever you hear varies directly, you're just going to go ahead and write that equals k. And what else do we know? Well, we know that when y is 10, x is 3. So we'll go ahead and plug those in. And that will help me find our constant of variation. So that'll be 10 equals k times 3, which means that k is going to be 10 divided by 3. And I'm going to go ahead and leave it like that. So after that, we're going to go ahead and get my general equation. And that is basically the original one with our new k value plugged in. So my general equation is 10 divided by 3 times x, because I figured out what k was. So now I can solve the rest of my problem for my specific solution. So using my equation I have here from the general equation, I'm now trying to figure out what y is going to be when x this time is 18. So y equals 10 divided by 3 times 18, simplifying, and we get y equals 60. And we're done. Again, so when you're working with a variation problem, there are 3 steps. First, you have to find your k, and that helps you fill out your general equation, and then you use your general equation for your specific solution. So the 3 steps. Let's take a look at example 6, Hooke's law. So first off, what is Hooke's law? Well, Hooke's law states that the distance varies directly as a weight when you're talking about the stretching of a spring. So the distance the spring stretches is directly proportional to the weight. And that is Hooke's law. So knowing Hooke's law, can we go ahead and find k? Yes, we can, because we are given a piece of information here. We're already given a variation. 4-pound weight stretches with 3.4 inches. So I'm going to go ahead and let W equal the weight. So let me write that here. Oh, let me actually leave a little space. Because I'm not already given a variable, I have to state my variable. So let W equal the weight. And then let D equal the distance that the string is going to stretch. So to find K, I need to write my equation. And first I know that distance varies directly with the weight. So that's going to be D equals K times W for the weight. Now to find out my constant, I'm going to use the first piece of information. So I know that W is going to be 4, and my distance is going to be 3.4. So let's go ahead and plug that in. So 3.4 equals K times my W, which is 4. Again, I'm not going to simplify this all the way out. I'm just going to write 3.4 divided by 4 equals K. And then I'll go ahead and plug that in to my general equation. And my general equation is going to be D equals 3.4 divided by 4W. And that right there is my general equation. So now I'm going to go ahead and use my general equation to solve my specific question in this problem, which is, how far will an 8-pound weight stretch the spring? So now we're going to go ahead and solve my specific problem with my equation. All right, so we're given the 18-pound weight. So we're given the weight is 18, and we're trying to find how far, which is D. So we're trying to find the distance when the weight is 18. Okay, again, we're trying to figure it out when the weight is 18. So multiplying that out, we're going to get distance equals 15.3. And again, this is a word problem, so let's go ahead and write our answer. So the spring will stretch 15.3 inches. Again, make sure to use your units that you're given. So let's take a look at the last problem, solving formulas. So example 7, solve the formula for the given variable. Now we're given A equals 1/2 H times B plus b. And careful, if we're given a capital B, stick to a capital B. So in this case, capital B and lowercase b are not the same. So be careful about that. And we're asked to solve for h. So where is h in my problem? H is right here. And what's happening to it? It's being multiplied by a half and multiplied by b plus h. So I want to get it by itself. To undo that, I'm going to go ahead and multiply both sides by 2 to cancel out that fraction. And then I'm left with 2a equals h times b plus b. Now, is h by itself yet? No. It's still being multiplied by the b plus b. How do we undo multiplication? Well, let's go ahead and just divide by b plus b. And then we're left with 2a divided by b plus b equals lowercase h. And we're done. That is our solution. So that is it for this section. If you have any questions, please email me.